This is Mrs. O'Neill for AP Chemistry, Chapter 17, Section 3, Part 2, Problems Dealing with Strong Titrations. So pause the video, make sure to fill in the notes, and then play to hear my words. So when we're dealing with a strong acid and strong base, our equivalence point is 7. Why? Because we're making water. So at the equivalence point, basically what's happening is our H pluses and our OH minuses are all used up because they've all reacted with each other to make that water. So on the titration curve, just like anything else, there's 3 points. The first part of the titration curve is that strong acid is dominant. Now, between that pH and equivalence point, or the initial pH and the equivalence point, of course, that pH is going to increase slowly, and then that rapid where that equivalence point meets 7. And then, of course, after that equivalence point, your excess strong guy is going to whatever we're adding into our flask, that excess guy is going to be dominant. So again, strong means any strong acid with any strong base. One of the other reasons why I had you memorizing this list over and over again. So this is our titration curve. We want to remember that this is not a buffer, okay? A buffer only deals with weak stuff. This is not a buffer because it's strong. Our equivalence point is at 7, and look how long this line is. And then over here would be that excess base. So again, this is how much volume of the base that is being added. So we're starting out with an acid here. Of course, our pH is very, very low. We have our not buffer area. This is still just our acid being dominant. At some point, we've made water. All of the H and OH has reacted with each other to form water. That's why our pH or at the equivalence point is 7. And here now we have an excess of base because that's our strong guy now, our excess strong guy of what we're adding to our flask. So again, just another look at what that titration curve looks like. A couple of things to notice is how long this this spike is in our graph. And of course, right in the middle would be our equivalence point. So you might want to pause the video. You should have already seen some of these graphs and what's going on at the molecular level, but just notice again, here is our starting point and what that looks like. Here is the area, again, not the buffer area, but just the part where the acid and base are reacting with each other to form that water. So what's in there? We also have this area of the equivalence point. Notice the H plus is completely used up by the OH minus, so we don't see any or either of those, I should say. And then of course past the equivalence point we have our, again on the molecular level, now we see the OH is dominant. So hopefully all of the parts of the titration curve make sense, as well as what each part looks like on the molecular level and what are the components in there. So if we want to see the other way, how about if we start with a strong base and we're titrating with a strong acid? It just is the other way, right? So again, we're starting with a strong base. Our equivalence point is still 7. We still have a long line here, and then our acid would be dominant. So give it some thought. Again, pause the video. The first thing I would suggest, however, is if it's talking about an acid and a base, titration and equivalence point, you have to first figure out, is the acid and base strong or weak? So hopefully you knew that it was strong, which means that the pH would be 7 at that equivalence point. No ifs, ands, or buts about it. So let's look at these problems. So one thing you might want to do this time is actually go through the PowerPoint, go through this video, looking at each of the steps, and then maybe going back and writing it in your notes. That's just a suggestion. Instead of kind of doing them along the way, I would actually listen to this at least twice. So pause the video, fill in the notes. Here are basically the steps to these problems. Because it's strong, first thing we need to do is find the moles of each of our strong guys, our strong acid and our strong base. Then we're going to compare. Do we have more H plus or do we have more OH minus? That's going to be really important because are we finding pH or are we finding POH at the end, right? It depends on which one we have more of. Then this is, again, really, really important. Step 3 is really important because now we're dividing by the total volume, which means because we're making that mixture, right, we have how much moles of excess, but because of that mixture, we're adding the acid and the base volume together. That's how we're going to get our new concentration. Again, this is one of the reasons why in that ice box, which we are not using for strong, right? There's no ice box. Ice box is only for weak guys. But when we dealt with the ice box, we always dealt with moles first. The reason for that is because we always then had to divide by the total volume. So we will see this in the next video when we do calculations for strong weak guys or weak strong guys. So after that, now we have our new concentration of the H plus or the OH minus. It depends on which one was dominant, right? And then, of course, we're going to solve for the POH or, and then the pH. But again, it's always about pH, always, always, always. So even if you are solving for OH minus, at the end, you always still have to convert that to pH. So here's an example. And one thing I noticed again on your videos, that other packet of videos that you were doing, I know that you could use the MAVA equals MBVB, the acid and the base, but we are not finding the new concentrations here. We are finding pH. So we cannot do this, okay? We cannot do this. We need to be able to find pH in a different way. We need to know which one we have more in excess of. So there's an A, B, C, D, okay? So again, if you want to at least listen to all of A first, and then maybe try to do B, C, and D on your own, it's up to you. But I would listen, again, strong suggestion, listen to all of A, and then rewind and go back and write it in your packet. So what's going on here? So calculate the pH when we have 0.1 NaOH solution's been added to 50 milliliters of 0.1 HCl. Aha, so this HCl is not changing. We have 50 milliliters of this 0.1 molar solution of HCl. That's not changing. So in our ABCD, I will say that the H plus original is always going to be there. That's going to be that same value all the time. What's going to change though is the base. And like I did here, hopefully it makes sense to you, is I've also color coordinated. So I've always made the acid red and the bases blue. So hopefully that makes sense. And I've always tried to use water in green as our neutral guy. Okay, so we're going to need the moles of the H plus originally, and that's going to stay the same. Then we got to figure out the moles of the OH that we've added. Okay, so the moles of the H plus after neutralization, that's going to be our final thing here, right? We're going to find the concentration of our H plus to find that pH. Okay, so step one, moles of each. Hopefully you know how to do this pretty quickly now, right? We're going to take our liters times our molarity to get moles, bada bing, bada boom, and you should get that as an answer. So it's always liters times molarity to give us moles. Do the same thing for our OH minus. Again, this is 49 milliliters times the 0.1 is going to give us that 4.9 times 10 to the negative 3. So now we have to do some comparing, right? Step two is comparing. Which one of these do we have more of? Is the H plus dominant or is the OH minus dominant, or are they equal, right? That's going to be also a step if they're equal to each other. Well, in this case, there's more H plus than OH, right? So we have H plus is greater than that OH minus. So we're in that acid in the very beginning of that titration curve. So each of those OH have really been reacted. Now we need to know how much H plus now is left behind. In other words, how much of this H plus do we have more of? Well, we're just going to easily subtract. We're going to take the 5 minus the 4.9 and get the 1 times 10 to the negative 4. So that's how many moles of H plus we have left over. Step three, now we got to deal with that new concentration. So remember, we have moles of the H plus in excess. After the titration, we have a new volume because we started with the 50 milliliters of HCl, and now we've added the 49 milliliters of the OH minus or of the base. So we add that volume. So again, molarity is always moles divided by liters, but again, this time it's moles of that H plus divided by the liters of the entire solution, and we get that as our value. Now we have our H plus, pretty easy. Now we can just calculate pH. So our H plus concentration is 1 times 10 to the negative 3 molarity. Now we take our negative log of that to find pH, again, plugging and chugging, and we get 3. So now I'm going to start going through B, C, and D, but I strongly suggest maybe pausing the video, going back, rewinding, and trying to truly understand all 4 of those steps. So here's B. Again, step 1, moles of the H plus stays the same. The moles of the OH is now slightly different because I've added more volume. Step 2, we're going to compare which one do we have more of, and again we have more H plus. So now step 3, we're going to find that new concentration. So first our new volume, adding the 50 plus the 49.9, and now we're going to do our division. Step 4, we're now going to calculate pH. Well, if we know the concentration of H plus, we take the negative log and get 4. So can you do part C? So part C, here we go. Part 1, right? Comparing the moles. Moles of H is the same. Moles of OH is now slightly higher. Uh-oh. So part 2, H plus is less than the OH minus. By how much? Well, now we have 1 times 10 to the negative 5 moles of the OH, but we still now need to figure out that new concentration of the OH minus. So again, new volume, and now our concentration is that many moles divided by that whole total volume of both the acid and the base. And now, a little bit different for step 4, now we're doing the POH, right? Because it's the OH concentration, it's the POH, and then subtract that from 14 to actually get the pH, because they're always asking about pH. Now letter D, if I were you, at this point you should be able to figure out all of the components and all of the steps. So pause the video and see if you can get the answers for D, and I'm just going to click away. So hopefully you got that, and hopefully it made sense. It's the same thing over and over and over with something strong. The biggest thing to understand here is which one do you have more of, so you know at the end, are you solving for POH first and then pH, or if you're solving for the H plus right away, you can go straight to pH. So example 2, see if you can again work this out. We have again HCl is added now to the NaOH. So we have different quantities of HCl added to the NaOH, but the steps are the same. The only difference here is that you are starting with the same amount of OH plus each time. So can you do A and B? It's the same calculations each time. And I'm just going to kind of click through and maybe say something here and there. So step 1, if you haven't done it already, find the moles of each acid and base. Hopefully, again, that's original, and it's always going to be that. So when you get this value, that's going to be the same value no matter how many different volumes they give you of adding the HCl. And again, I try to also color coordinate as well. The red's always the acid and the blue's always the base. So then here's your H plus. So step 2, we're comparing. So there's our values of OH minus and H plus. So which one do we have more of, and by how much? So we have to do a little subtraction, because remember that reaction is happening. The H plus is reacting with that OH minus to form that water. So that's why we have to figure out which one do we have more of now in our pot, because the other guy goes away. It's the limiting reactant. Step 3, new concentration. Again, new volume, add those up because it's a mixture. Our OH minus, we have more of. And of course, step 4, calculate pH, but we need to do the POH first because it's the OH concentration that's dominant, and subtract from 14. So can you do B? And hopefully that makes sense, because now we had more H plus in our pot. Okay, we will see you in class and do some practice problems.